Hello, welcome to Overview of Web and Cloud Development. When you're starting out as a web developer, it can be difficult to determine what you need to learn and what order you should learn it in. Understanding how familiar websites are constructed and delivered to you is a good starting point. Let's review the basics of how you interact with a website. You launch an internet browser. There are lots available. Google Chrome, Microsoft Edge, Mozilla Firefox, and Apple Safari are some of the most popular. The browser has an address bar into which you enter a URL, like www.ibm.com. The browser then contacts the server with the name and requests the information that makes up the website. The server then sends a response, which contains the data that the client requires to display the website. For most websites, the server will return HTML, which defines the structure of the page but doesn't look very attractive, CSS, which adds style and flair to the page, and JavaScript, which adds interactivity and dynamic content. Content displayed by websites can contain elements that are either previously stored on the server, called static, or generated each time they are requested by the client, called dynamic. Dynamic elements can involve information coming from other systems and applications, such as databases. Most websites contain static and dynamic elements to provide the best user experience. Cloud applications are similar to websites in that they request content that a server returns. Cloud apps are built to work seamlessly with a cloud-based back-end infrastructure, cloud-based data storage and data processing, and other cloud services, making them very scalable and very resilient. The environment for building websites and cloud applications is divided into two primary areas, front-end and back-end. The front end deals with everything that happens at the client side, everything the user can see and interact with. You can choose to specialize in front-end coding using HTML, CSS, JavaScript, and related frameworks, libraries, and tools. The back end deals with everything that happens on the server before the code and data are sent to the client. The back-end coding usually handles the logic and functionality that make the website or app work, and the authentication processes that keep data secure. Back-end developers may also work with relational or no SQL databases, even collaborating with database administrators in bigger projects. Full-stack developers have skills, knowledge, and experience in both front-end and back-end environments. Whichever way you choose to specialize, you will need the appropriate tools to help you work. The first tool most developers add to their resources is a code editor. Developers also need tools to integrate, build, compile, and debug code. Integrated development environments, or IDEs, incorporate some of these additional capabilities beyond just code editing and make it easier to build and manage your code. Good IDEs support multiple languages and integrate with management and storage tools like Git and GitHub. Other useful features are custom extensions and themes for supporting your working style and environment. Examples for code editors and IDEs include Sublime Text, Atom, Vim, VS Code, Visual Studio, Eclipse, and NetBeans. In this brief overview, you learned about the basic communication between client and servers, how websites are built and displayed. Front-end development is about what happens on the client side. Back-end development is about what happens on the server. Full-stack development includes both front-end and back-end development. IDEs will help you create and manage your code. Internet websites offer lots of different services, one of the most popular being online shopping. When you explore an online shopping website, navigating through pages, choosing different product categories, or comparing products, you are interacting with the front end of a website. Let us see how the front end of a website is developed by front-end developers. For this, we need to understand how a website is made. To create a website, web developers usually use hypertext markup language, HTML, cascading style sheets, CSS, and JavaScript. These languages are designed to work in conjunction with each other. HTML is used to create the physical structure of a website. The physical structure contains elements such as text, links, images and videos, page dividers, and buttons. The HTML code ensures a proper formatting of all text and image elements so that browsers display the page consistently. The backend developer codes the structure of the website. A website is like a house which has only been constructed. Just like we need interior designers to add style to a space, we need front-end developers to add the necessary glamour and appeal to a website. When you order products from any website, you realize that the pages have a pleasing font, attractive colors, and are easy to navigate. Developers use CSS to create stylish websites. CSS provides front-end developers with a standard method to define, apply, and manage different sets of style characteristics for a website and each of its components. CSS ensures uniformity in look and feel, style, colors, fonts, designs, and layouts. So, HTML is used to create the structure, and CSS is used to design it and make it appealing. CSS is also used to create websites that have cross-browser compatibility, which means that they are compatible with multiple browsers and multiple devices, such as PC, mobile devices, iPads, etc. Online shopping websites are intuitive, interactive, and quick to load. This is where JavaScript comes into the picture. JavaScript is an object-oriented programming language that is used in conjunction with HTML and CSS to add interactivity to a website. For example, you use HTML to add a login button to a page and CSS to style that button. Then you use JavaScript to add login functionality to that button. A new front-end development language is Syntactically Awesome Style Sheets, SASS, called Sass. It is an extension of CSS that is compatible with all versions of CSS. Sass enables you to use things like variables, nested rules, and inline imports to keep things organized. Sass allows you to create style sheets faster and more easily. Another language that is being used now is Learner Style Sheets, LESS, or LESS. LESS enhances CSS, adding more styles and functions. It is backwards compatible with CSS. LESS.js is a JavaScript tool that converts the LESS styles to CSS styles. Using all these languages, websites are designed as reactive and responsive. Reactive, or adaptive websites, display the version of the website designed for a specific screen size. For example, a website can provide more information if opened on a PC than when opened on a mobile device. Responsive design of a website means that it will automatically resize to the device it is being accessed from. For example, if you open up a product's website on your mobile device, it will adapt itself to the small size of the screen and still show you all the features. A JavaScript framework is an application framework that is written in JavaScript. Programmers can manipulate the different functions, use them wherever required, and can create device-responsive applications. A few examples of several frameworks being used are Angular Framework, an open-source framework being maintained by Google. Angular frameworks allow websites to render the HTML pages quickly and efficiently. It has built-in tools for routing and form validation. React.js has been developed and maintained by Facebook. It is a JavaScript library that builds and renders components for a web page. It is not a complete suite of tools. For example, routing is not a part of this framework and will need to be added using a third-party tool. React.js only helps build and drop components into a page. Vue.js is maintained by the community, and its main focus is the view layer, which includes user interface, buttons, and visual components. It is flexible, scalable, and integrates well with other frameworks. It is very adaptable. It can be a library or it can be the framework. The task of a front-end developer evolves continuously. The technologies are upgraded constantly, and so front-end developers need to keep upgrading the websites that they create. The websites that they create should work in multiple browsers, multiple operating systems, and multiple devices. Welcome to the importance of back-end development. A front-end developer creates websites and cloud applications using HTML, CSS, and JavaScript to create what the user sees and interacts with in the client software. A back-end developer creates and manages all the resources that are needed to respond to the requests that the user makes through the client. The back-end developer's tasks focus on enabling the server infrastructure, or back-end, to process requests, supply data, and provide other services securely. Front-end and back-end developers must work together very closely. Each needs to understand the requirements of the solution and how their respective parts will interact before the development process can begin. Throughout the lifecycle of the website or cloud app, front-end and back-end developers collaborate to resolve issues and add functionality. How does the work of a back-end developer affect you as you are browsing the internet or using a cloud app? Think about it like this. When you're shopping online, what happens to the data you enter? Your login information, your product searches, your payment info. The back-end processes all of these things, and the back-end developers write and maintain the parts of the application that process the inputs. Let's think about your experience as you explore an online shopping site and make a purchase. As you search for products, your search request is submitted to a web application, which then retrieves the data from a separate database and serves it back to the client for display. To facilitate this, a back-end developer must understand the language that the web application uses, how to query the database for the correct data, and how to bring the two together. Even a simple task like navigating around the site can require the skills of a back-end developer. Many sites have restricted areas that are only available to users who have an account and have logged in. User account management, authentication, and authorization can be the responsibility of the back-end developer too. Once you've decided what you want to purchase, you must add it to your cart and make a payment. The purchase process requires you to submit sensitive information, such as your address and credit card number, and the back-end developer must ensure that this data is securely handled and stored. Front-end client interactions, whether a request for data like an image, accepting input from a user filling out a form, or securing sensitive information like a credit card number, all require different services from the back-end server. Each request needs to interact with the back-end in a different way. Back-end developers use APIs, routes, and endpoints to process incoming requests. An API is code that works with data, usually using JSON or XML. APIs have set rules and structure. A route is a path to a website or page that the user interacts with. Routes generally take user input and show results based on the input. An endpoint may be an API or may simply be a path. When a request from the front end arrives at the back end, it is routed to the correct service. If the back end has an endpoint defined for the request by using routing, the request will be addressed and replied to. If the endpoint is missing, the server returns a 404 error. Back-end developers must create and maintain this server-side routing. Along with back-end APIs, routes effectively allow the front-end client to plug into the correct socket at the back end. APIs provide a mechanism for cloud apps, mobile apps, and other types of software to access resources from the back end. To perform all this back-end development, you will need to be familiar with at least one back-end language and its associated frameworks. Among the most popular languages today is JavaScript, which was originally designed to run in web browsers, adding extra interactivity and dynamic content to web pages. JavaScript is also being used on the back end, with new releases adding server-side functionality. JavaScript has many frameworks, but two of the most well-known are Node.js and Express. Python is another popular language. It's very flexible and easy to learn. Python has wide functionality. It can be used for everything from creating web pages to connecting to a database to performing data analysis. Two well-known Python frameworks are Django and Flask. Back-end developers often work with data and databases, so you will also benefit from learning some SQL. To help handle requests from databases, back-end developers can use Object Relational Mapping Tools, or ORM, to connect to the databases and retrieve the correct data. Although an ORM can hide some of the complexity of querying databases, it's useful to understand the fundamentals of databases so that you can troubleshoot any issues that arise. The day-to-day tasks of a back-end developer focus on the behind-the-scenes functionality that keeps websites, cloud apps, and mobile apps up and running. Back-end development covers a wide range of technologies, from managing user accounts, authentication, and authorization, to ensuring that sensitive data is stored and transferred securely. Back-end developers also work with databases, retrieving, processing, and storing data as required. Life for a back-end developer is varied, challenging, and ever-changing.
Welcome to Teamwork and Squads. After watching this video, you will be able to define teamwork and describe the advantages of collaboration in software engineering, and describe squads. By definition, a team is a group of people working together towards a common aim. Within a team, you'll find a range of different people with different skills, experience, and talents. Each person can give their attention and effort to the things that they are good at, and by working alongside others on tasks outside their current repertoire, they can expand their skill set. Working in a team promotes creativity. Collaborating with others gives you the opportunity to discuss ideas and challenge one another's thinking about a subject. Good teamwork is empowering. Positive attitudes and behaviors can impact the rest of the team and create positive results. Working well as a team doesn't always come naturally, but there are some things you can consider to help your team succeed. Each member needs to trust and respect the other members of the team. This generally comes with time, but depends on all of the members contributing equitably. Defining and agreeing on goals for a project is essential so that the whole team knows what they are working towards. And you also need to define and agree on roles to avoid any duplication of effort or missed tasks. Working with each member's strengths is important to make the most of the talent within your team, as is celebrating success and analyzing problems. Communication is vital in a team environment. Ensure that you choose a method that works for everyone so you know that the whole team is seeing and responding to information. So, what does teamwork look like in software engineering? Teams often start projects with a kickoff meeting where they plan how they will complete the project, assign tasks, and agree on goals. Throughout the lifetime of a project, you're likely to have a whole team and/or sub-team meetings to review progress and plans. Design and code reviews can be requested at the team level and undertaken by whoever has availability at that point in time. Also, team members might present walkthroughs of their sections of responsibility to the rest of the team so that the whole team has oversight of all parts of the project. And key team members will likely present walkthroughs to stakeholders at various times during the project. When a project is complete, retrospective meetings may be held to review what went well and what could be improved in future projects. You may have a mentor who may or may not be in your current project team. You might also be asked to be a mentor. Sometimes team mentoring is used so everyone can learn from each other. And some groups also have teams working on internal projects, such as defining code standards, maintaining or updating legacy cross-project code, or reviewing potential new software for usefulness to the team. Good teamwork can bring many benefits to a project. Working alongside others can encourage creativity and enable you to take advantage of each person's strengths while also allowing them to gain knowledge and skills from other members of the team. When working as part of a team, software engineers are more likely to adhere to corporate coding standards and regularly document their code. The additional accountability that teamwork creates results in better quality code, fewer bugs, and more maintainable code. From a software engineer's point of view, working as a team can reduce stress because there's always someone to turn to and get help from. And having someone to discuss problems with can help you to increase your understanding and resolve more issues by yourself. By working in a team, each member has a greater idea of the bigger picture, resulting in a more coherent overall solution. Some organizations that follow agile development methodologies may call a team a squad. Typically, a squad is a small team of up to 10 developers. It is likely to consist of a squad leader, who acts as the anchor developer and coach for the squad, and a few software engineers who develop and implement the product features and test cases. It may also include 1 or 2 user experience developers or designers. In some squads, the developers may work together in pairs to practice pair programming. You'll learn more about pair programming in another video. In this video, you learned that software engineering teams meet regularly throughout the duration of a project. Good teamwork encourages creativity, shares knowledge, and results in better quality code. And squads are small teams used in agile development. In this video, we will hear from experts discussing how teamwork is important in software development and how teams work together.
Yeah, so teamwork is very, very important in the world of software development. As a software engineer, you're not just going to be sitting at your desk coding all day. One of the most important aspects of working on a team or on an engineering team is communication and knowing how to collaborate and speak with your team members about the code you've written, especially if you're going to a UX designer and say, hey, here's what I can do, and your spec is a bit off. Can we massage your specs a bit just so we can meet the coding requirements?
Incredibly important. While I think it's possible for a single person to engineer and deploy and run software, I think doing it as a team is both more impactful and gives you more potential to do bigger and greater things. I think it's also just a more fulfilling process when you're building something with a group of individuals. I think without the support structure, it's hard to build something and support it and maintain it just by yourself.
So teamwork to me is essential because we're talking to each other all day, and we're not only talking to our tech leads or senior engineer, we're talking to product managers, we're talking to UX designers, we're talking to business analysts, we're talking to data analysts, and so on and so forth.
You have the support system, you have diversity of opinions and perspectives in terms of how you go about building it. It's more satisfying. You kind of can take larger risks because you're in it together and you're there to support each other. I think the celebration of a job well done is a lot more, it's a lot more fulfilling when you're doing that with someone else. But I think it just gives you both kind of a larger range of scope and a larger sort of risk portfolio, if you will, and you're able to, I think, just get a lot more done, have a lot more checks and balances, and really gives you, there's a less likely chance that you're going to miss something or you're going to make a mistake. There's a lot of support there.
And so every project I've worked on has had at least 3 other people that I have needed to communicate with and to support, to be a reliable resource for them, to go to them for questions. Like I always have to be talking to somebody about something. So teamwork is crucial. Like you can't work in an isolated silo forever. At some point, you have to talk to someone else.
Building a product takes a lot of people. A lot of us come together to make a whole and to get the product shipped to production so our users can use it. And so teamwork is imperative.
Welcome to pair programming. After watching this video, you will be able to describe pair programming and compare different styles, and list the benefits and challenges of pair programming. Pair programming is an extension of teamwork where two developers work side by side at one computer. They can either be physically at the same computer or work virtually via video link or shared screens. The former is the preferred option, but virtual pair programming can also be productive. Pair programming is a type of agile development where two developers can plan and discuss their ideas continually as they create a solution, generally resulting in a better end product. And there are various styles of pair programming. Driver-navigator style is the most common style, where one developer is the driver typing in the code, and the other is the navigator reviewing the code as it's written and giving directions where to go next. The navigator also keeps an eye on the bigger picture of the overall solution. When working in this way, it's important to regularly swap roles to keep both of the pair engaged across the whole task. Ping-pong style incorporates test-driven development. For each task, one developer writes a failing test, and then the second developer writes code to pass that test. For each new task, they swap roles, so regularly changing who writes the test and who writes the implementation. The two developers work together at the end of each task, refactoring the successful code to refine and improve it. Strong style pair programming is a good way for junior software engineers to learn from more experienced ones. The defining rule for this is that for an idea to go from your head to the computer, it must go through someone else's hands. So the more experienced of the pair is the navigator, and the driver learns from witnessing their implementation and thought processes. For this to work well, the driver shouldn't challenge any ideas until the full implementation is complete, so as not to interrupt the flow of ideas from the navigator. Now, pair programming has many benefits. It's a good way to share knowledge and skills from one developer to another or between the two, and a great way for a new team member to get up to speed on a project. As well as enhancing the technical skill of the pair, it's also a good way of building soft skills, such as communication and problem solving. Having two sets of eyes on the code often results in fewer typos, logic errors, and bugs. And it enables code reviews to be done on the fly. While this doesn't replace formal code reviews, it does enable another layer of review. Now, having two people thinking about a problem can result in multiple initial ideas, but is likely to result in the optimal approach being chosen earlier in the process. And although pair programming can take longer than individuals writing the same solutions, it's likely to result in better code with less time spent reviewing, testing, and bug fixing. There are also a few challenges to overcome. Working in a pair requires long periods of focus, which can be exhausting for the two programmers, and personal or other work commitments can impact the pair schedule. Sometimes one of the pair can end up controlling the entire process, resulting in a more typist programmer pairing, which doesn't benefit from any of the positives of pair programming. At other times, individual personalities may not work well together. When multiple sets of pair programmers are present, their discussions can result in a noisy environment for the other workers in the room. In this video, you learned that pair programming is an agile development technique where two developers work alongside each other. There are multiple styles of pair programming. And pair programming builds technical and soft skills, results in better quality code and solutions, and increases overall efficiency. First, we will begin by asking about their experiences with pair programming and about the benefits they associate with it.
At every job I've ever had, there have come times where you pair up with someone else. You get someone else sitting next to you at a computer, or you're sitting next to them at their computer. You're looking at a problem together, you're thinking about it.
Yes, I have actually. Some of the benefits are definitely working with an engineer who might be more of a senior engineer, because they have a lot of insight and they obviously have a lot of experience doing what you're probably trying to figure out how to do. And it's really great when it's someone who can both guide you, but also kind of take a step back and not take over at the same time.
I think pair programming can be very beneficial. I think when you're working with someone together, it's an opportunity to learn. I think pair programming can be very great in circumstances where someone is new to a team, new to a programming language, new to a set of tools, or a development environment that is new to them. Sitting next to someone who's an expert, I think, can both help you ramp up more quickly. It can help the team itself sort of understand where you are in terms of your own knowledge and journey, and help put you in a place to both succeed and utilize you and your skills as best as possible. It does help you get real-time feedback. You don't necessarily have to wait for code to be sent out to be reviewed, and you can kind of brainstorm together in real time on the actual implementation of it.
Ultimately, I try to keep in mind that the goal of pair programming is that everyone has inherent blind spots in the way that they think and the way that they approach a problem. And if you are talking to somebody else, they can point out what your blind spots are. And they're going to have different blind spots than you as well. So you can point out their blind spots.
What do you think are the drawbacks and challenges of pair programming?
I think that can be a con sometimes when you're working with another engineer and you're trying to pair program, is someone who kind of like takes over and then doesn't allow you to do your part or to learn, especially if they kind of like already know how to do something. So it's kind of like a double-edged sword. On the one hand, you want to get that practical experience of pair programming, and you want to get that experience from someone else. But at the same time, you want to make sure that you're learning.
I personally find pair programming to be a little frustrating because the ways I go about solving problems can be very different than the ways other people go about solving problems. And it's not that I have some special, unique, wonderful technique. It's just that everyone's brain works differently. And watching someone else go through their workflow of how to solve a problem, they're not clicking the exact same buttons that you are. And that can get very frustrating to me. And it's like, why are you using your mouse to click all of those things? There's keystrokes for it. Like, you could be doing this so much faster. And so I find it a challenge to do pair programming sometimes.
You actually need calendar time, so you need to be able to dedicate time to sit together and work together and have an aligned schedule. You could either be physical, you could do it virtually, but you need to make the time to do it. Pair programming can come with some overhead in terms of getting off the ground. So if you have a tight time crunch, competing priorities, maybe just not enough, there might be not enough time in the schedule to allow for it. That can be one of the cons. That it can, while you can get long-term, I think, efficiency benefits from writing the code together, because then support in the future will be easier because you have more people who know how the code was written and what the intent was. So there are definitely long-term benefits, but there could be some short-term costs to it. So there are trade-offs in that sense.
Welcome to Introducing Application Development Tools. Getting your cloud app from the idea stage to fully formed, written, and deployed is a long process, but there are many tools which will help you along the way. A cloud application developer's workbench includes version control, libraries, and frameworks. When many developers are working on the same project, knowing what order changes were made, thereby creating a new version of the source code, becomes overridingly important. Version control systems keep track of what changes were made when and by whom, and resolve any conflicts between changes. For developing your code, version control can be useful even when you are the sole contributor on a project. Properly used, it can give you a way to revert to an older version of your code if something goes wrong, and gives you some basic information about how the code developed over time. Version control functionality is generally tied to the storage system you are using, which is why a code repository is recommended, even for beginners. Git and GitHub are extremely popular for source code storage and management. Git stores files in repositories where you can track changes, split code into different branches for more focused development, and then merge them back into the main body of code. Libraries are collections of code, like standard programs and subroutines that you can use within your code. For example, you might want to include a navigational feature, like a carousel. A code library can supply you with the code for that so that you don't have to spend the time and energy creating one from scratch. Being able to reuse code in this way makes developing your app much quicker and easier. Multiple code libraries can be integrated into your existing project. As you discover a need for a specific function or feature, you can research an appropriate library. You determine when to call the required method as needed. The control returns to the program flow once the subroutine is finished. When you use a code library, you are in control. Code libraries are generally used to solve a specific problem or add a specific feature set. Either way, there are lots for you to choose from, so do your research. Here are some examples of code libraries. jQuery is a JavaScript library that simplifies DOM manipulation. Email Validator is a small library that checks an email address is correctly constructed and valid. Apache Commons Proper is a repository of reusable Java components. Frameworks provide a standard way to build and deploy applications. You can think of a framework as being a skeleton that you can extend by adding your own code, providing a scaffold on which to build your apps. The framework you intend to use must be determined early in your development planning and used right from the beginning. New frameworks can't be incorporated into an existing project. Your chosen framework dictates the architecture of your program and controls the program flow. The framework determines which subroutines and methods will be called when. When working with a framework, there is a specific structure that you must follow. The framework calls on your code rather than you calling on the framework. Frameworks are less flexible than libraries, allowing you less control, but they do provide good standardization and can help you create efficient code. To use an analogy, if you are a carpenter building a house, the framework is the frame that you add to, bricks on the outside, plasterboard on the inside, and so on. The frame acts as a guide for how the house is constructed. Here are some examples of frameworks. AngularJS is a JavaScript-based framework for dynamic web applications. Vue.js is a JavaScript framework focused on the user interface. Django is a framework that uses Python for web development. Frameworks define the workflow that you must follow, unlike libraries, which allow you to call functions as and when required. When using a framework, it can sometimes feel like you, as a developer, are not in full control of the development process. This sense of the framework and its predefined workflow controlling the development process is referred to as inversion of control. Frameworks that have a lot of control are known as opinionated. They have opinions on how their workflow should be used and remove a lot of the decisions you would otherwise have to make about how code is written, the location of files, and even file names. Frameworks often include their own libraries, which they can call when needed. Inversion of control allows you to create standardized apps and takes away a lot of the tedious configuration work, so you can focus on the code for your app. In this video, you've learned about some of the tools that you will utilize in your career as a developer, including version control, libraries, and frameworks. Welcome to more application development tools. Let's look at some tools which can help you get your app built and deployed. CI/CD, build tools, packages, and package managers. CI/CD refers to the practices of continuous integration and either continuous delivery or continuous deployment. CI/CD is a best practice for DevOps teams, enabling developers to deliver frequent changes reliably. Implemented through a build automation server, Continuous integration, or CI, ensures that all the code components work together smoothly. A CI build environment enables you to integrate newly developed code frequently, at least every day, if not every hour, depending on how quickly the project changes. Continuous delivery, or CD, begins where CI ends. The CI process automatically builds and tests your code, then CD deploys all code changes in a build to a testing or staging environment. A build tool transforms your source code into the binaries needed for installation. Build tools organize your source code, set compile flags, and manage dependencies. They are most important in environments where there are many interconnected projects with multiple developers contributing to each project. In these environments, it can be very difficult to keep track of what changes were made, in what order, what dependencies exist, and what needs to be incorporated in the next build. So automation is key to keeping everything running smoothly. Build automation can automate a wide variety of tasks that developers do in their day-to-day activities, like downloading dependencies, compiling source code into binary code, packaging that binary code, running tests, and deployment to production systems. You can initiate a build from the command line or from an IDE. There are two categories of build tools widely in use. Build automation utilities, which generate build artifacts like executables by compiling and linking source code. Build automation servers, which execute build automation utilities on a scheduled or triggered basis.
Some examples of build tools are Webpack, a module bundler for JavaScript, Babel, a JavaScript compiler, and WebAssembly, a binary instruction format that runs in your browser.
Now that you have your app developed and tested, you're ready to deploy. But how does that happen? The app needs to be simple and trouble-free for the user to install. So a commonly used technique is to collect all the necessary files and bundle them together into a package. Packages are archive files that contain the app files, instructions for installation, and any metadata that you choose. They have their own metadata too, including the package description, package version, and any dependencies, like other packages that need to be installed beforehand. Once you have bundled your app into a package, you can use a package manager to distribute it. Package managers take care of the tasks of finding, installing, maintaining, or uninstalling software packages at the user's request. Package management systems coordinate with file archivers to extract package archives, verify checksums and digital certificates to ensure the integrity and authenticity of the package, locate, download, install, or update existing software from a software repository, and manage dependencies to ensure a package is installed with all packages it requires. Some commonly used package managers for each of the major platforms are listed here. On Linux, Debian Package Management System, or DPKG, Red Hat Package Manager, or RPM. On Windows, Chocolatey. On Android, Package Manager. On Mac OS, Homebrew and MacPorts. Any libraries or utility code that is developed as part of the application is managed with the Cloud Application Package Managers. Here are some examples of package managers for popular languages. For Node.js or JavaScript, NPM. For Java, Gradle and Maven. For Ruby, RubyGems. For Python, pip and conda. In this video, you've learned about some of the tools that you will utilize in your career as a developer, including CI/CD, build tools, packages, and package managers.
Welcome to Introduction to Software Stacks. After watching this video, you will be able to describe software stack terminology, identify some commonly used software stacks, and list the benefits and challenges of different software stacks. A software stack is a combination of technologies that include software and programming languages. Developers use a software stack to create applications and solutions such as web and mobile apps. The set of individual technologies is stacked in a hierarchy and work together to support the execution of an application. The higher levels in the stack provide tasks or services for the user, and the lower levels interact with the computer hardware. Software stacks typically include front-end technologies such as programming languages, frameworks, and user interface tools, and back-end technologies such as programming languages, frameworks, web servers, app servers, operating systems, messaging applications, and databases. You might hear the term technology stack used in place of software stack. However, a technology stack is a broader term that includes hardware and infrastructure, like virtual machines, containers, storage, and load balancers, as well as the software stack. The simplest implementation of a software stack consists of a presentation layer, a business logic layer, and a data layer. However, more complex applications use more complex stacks, which could include software for virtualization, scheduling and orchestration, runtime environments, database connectivity, networking, and security. The software and services that make up a stack can be from a variety of sources, from internal resources to third-party providers to cloud providers. There is no formal definition of the structure of a stack, the only rule being that the software and the services included must support an application's development, functionality, or deployment. When you're using a software stack, you don't have to use all of the available layers, you only need to use those which are relevant to your solution. There are many different examples of software stacks. The Python Django stack uses the popular Python programming language alongside the Django web framework. This combination is all open source and commonly used for large-scale, fast-changing web applications. The Ruby on Rails stack uses the Ruby programming language with a server-side web application framework. Ruby on Rails is great with JSON or XML for data transfer, and HTML, CSS, and JavaScript for front-end development. And the ASP.NET Stack includes Microsoft technologies such as the ASP.NET MVC framework, the IIS Web Server, SQL Server, and Azure. You'll learn more about the LAMP, Mean, MEVN, and MERN stacks next. The LAMP stack runs on the Linux operating system. It uses the Apache HTTP or web server, MySQL databases, and the PHP programming language. LAMP is an example of an early incarnation of a software stack designed for building websites and cloud applications. All its constituent parts are open source and loosely coupled, so it's easy to swap different options into the stack. For example, you could choose to use PostgreSQL instead of MySQL for your database server, changing the LAMP stack to be the LAPP stack. Similarly, you could use the Python programming language instead of PHP. The Mean stack uses a MongoDB database with an Express.js web application server framework, the AngularJS framework for front-end JavaScript development, and the Node.js platform for server-side scripting. The Mean software and services are platform agnostic, free, and open source. And there are other stacks related to the Mean stack, including the MERN stack, which replaces AngularJS with React and is a flexible and high-performing framework for developing front ends, and the MEVN stack, which replaces AngularJS with Vue.js. Vue is a lighter-weight JavaScript framework with less capabilities, but it can provide better performance than AngularJS. Let's consider some advantages and disadvantages of 3 different software stacks: Mean, MEVN, and LAMP. Mean is a free and open-source JavaScript software stack used for building web applications. The biggest advantage of the Mean stack is that all of the parts use JavaScript, so developers only need to know a single language. The stack is also open source, which means the cost is lucrative to businesses, and there is a lot of documentation and reusable code for developers to use. Development can happen quickly because Node.js has a huge collection of free, reusable module libraries. However, the mean stack may not be well suited for large-scale applications. When using Express.js, the business logic often resides on the server, preventing the reuse of some services, like batching operations. And MongoDB is great for unstructured data, but it doesn't provide the same level of functionality as a relational database. The MEVN stack is a web stack, like Mean, but it uses Vue.js instead of AngularJS for user interfaces. MEVN and Mean stacks have similar advantages, but Vue.js is a much newer technology and doesn't have as many reusable libraries as AngularJS. Like Mean and MEVN, the software and services in the LAMP stack are open source, meaning that there are lots of reusable chunks of code available to the developers. And because LAMP is one of the oldest software stacks, it's easy to find support and reusable solutions. However, because the Linux operating system is an integral part of the stack, it isn't as flexible as Mean and MEVN, which are platform agnostic. MySQL is a relational database, so the stack cannot take advantage of unstructured data. The other disadvantage of the LAMP stack is that the back end runs on PHP, Perl, or Python, whereas the front end uses JavaScript and HTML, making it harder for developers to switch back and forth between the Mean and MEVN stacks, which use JavaScript throughout. In this video, you learned that software stacks are a combination of technologies for creating applications and solutions. Software stacks can range from simple 3-layered systems to many layers. There are numerous types of software stacks for different developers and environments. The biggest advantage of the Mean stack is that all of the parts use JavaScript, so developers only need to know a single language. And the LAMP stack on Linux works well for relational data. In this video, we will hear from experts discussing their favorite tools and technologies for software engineering projects.
Our team uses Git and GitHub every single day for all of our projects. We use it for tracking code, we use it for collaboration, and we use it for tracking bugs, features, and tasks for all of our projects.
I believe most open source projects are now using Git. Every project I've contributed to, whether open source or closed, has used it. Git's true value is most apparent when you're working on a team with multiple people, at which point you'll be glad to have things like feature branches and pull requests. But even if you're working on a project where you're the sole committer, I recommend using Git, and in particular GitHub, for the community aspect.
So if you are a front-end developer, if you understand JavaScript, then picking up backend using a framework like Node.js is not that much of a stretch. I actually started building static websites, and then slowly learned how to put in dynamic content using JavaScript, and then I had to use Java or PHP to build my backend systems on the server.
For front-end development, you're primarily using HTML, CSS, and JavaScript. If you're very front-end focused, you might want to try out an IDE built for that specific purpose, such as brackets. If you want to keep things more general, I recommend VS Code. In either case, I recommend installing IDE extensions for automatic formatting and linting of your code using Prettier and ESLint. These will help you catch issues as early as possible. For backend development, the tools are quite a bit more varied, so it's hard to give specific recommendations, but if you choose Node.js, you'll be able to use some of the same tools that I mentioned for front-end development. Otherwise, I recommend just looking into what IDE extensions are available and what linters and auto formatters are available.
JavaScript is a very powerful language. It lets you do pretty much anything you can imagine, including shooting yourself in the foot if you're not careful. The practices I typically follow with JavaScript include proper scoping of variables and functions, and writing unit and integration tests for my features.
React.js was developed at Facebook, very popular. Angular is a framework operated by Google that allows for development of single-page applications. SPAs. jQuery is possibly the most popular and oldest library out there, created by John Resig in 2006. And jQuery is frequently used with both Angular and React. Backbone is a lightweight JavaScript library that is very popular. In terms of backend languages and frameworks, Node.js is an open source server-side platform built on the Google Chrome JavaScript engine. It uses an asynchronous single-threaded architecture that allows it to serve a very large number of concurrent connections. Flask is a framework used on Python that is popular with Pythonistas. And the Spring framework based on Java has been around for years and remains popular.
We use React JavaScript framework. It is better than Angular in terms of speed and efficiency. React is easier to learn than other JavaScript frameworks, which makes its adoption in the team easy. It also resolves the problems related to cross-browser issues. Another great feature of React is the use of JSX. JSX is helpful when working with UI inside the JavaScript code. It helps React to show more useful error and warning messages.
My favorite front-end JavaScript framework would be React.js. I love the whole component-driven design and architecture that you have to follow when you create a React.js based application. I also like the idea of props and states to hold the state of your application.
By using Express.js for backend development, we are able to scale applications quickly. We can code both frontend and backend with the help of JavaScript easily by using Express.js. Express.js is supported with the Google V8 engine, with the help of which you would be able to get higher performance without any lag or error in processing. It also supports the caching features, so you would not have to re-execute the codes again and again. Moreover, it will help web pages to load faster than ever.
When working with Node.js, I'll give you two of my favorite packages that I use on a daily basis. So first is making requests to web services. I use a library like Axios that helps me create these requests with the right headers and also provide me with callback functions or promises to be able to handle the responses that come back. My second package would be when I'm working with databases. I'll use NPM packages more likely than not to talk to an external database, regardless of if it's a relational database or a NoSQL database.
So when writing JavaScript, I really like to take advantage of the features in ES6 because it can make my code look cleaner, easier to read, and just more beautiful, such as the arrow functions or the ... operator. And so I encourage you to, after learning JavaScript, dive into ES6 a bit and have fun with it.